Hi, today we are going to see about machine learning. In the real world, we are surrounded by humans who can learn everything from their experience with the learning capability. And we have computers or machines which work on our instructions. But machine can also learn from experience or past data like human does. What is machine learning? A subset of artificial intelligence known as machine learning. It focuses primarily on the creation of algorithms that enable a computer to independently learn from data and previous experience. Without being explicitly programmed, machine learning enables a machine to automatically learn from data, improve the performance from their experience, and predict the things. Machine learning algorithms create a mathematical model that, without being explicitly programmed, aids in making predictions or decisions with the assistance of sample historical data or training data. For the purpose of developing predictive models, a machine learning brings together statistics and computer science. Algorithms that learn from the historical data are either constructed or utilized in machine learning. The performance will rise in proportion to the quantity of information that we provide. How does machine learning work? A machine learning system builds prediction models, learn from the previous data, and predicts the output of new data whenever it receives. The amount of data helps to build better model that accurately predicts the output, which turn affects the accuracy of the predicted output. Instead of writing code, we just need to feed a data to generic algorithm which build the logic based on the data and predict the output. The block diagram shows first we have to input the training data, and the training data it inputs the machine learning algorithm. We get a new building logical models, and then we get the new data. Features of machine learning. Machine learning uses data to detect various patterns in a given data set. It can learn from past data and improve automatically. It is data-driven technology. Machine learning is much similar to data mining, as it also deals with huge amount of data. Need for machine learning. Machine learning mainly needs to solving the complex problems which are difficult for human, and also decision making in various sectors including finance, finding hidden patterns and extracting useful information from the data. Classification of machine learning. Machine learning classified into three types. Number one, supervised learning. Another one is unsupervised learning and reinforced learning. Supervised machine learning. Supervised machine learning is the type of machine learning in which machines are trained using well labeled training data, and on the basis of data that machines predict the output. The labeled data means some input data is already tagged with some correct output. For example, the training data provide the machine's works, and as the supervisor that teaches the machine to predict the output correctly. Supervised learning is the process of providing input as well as correct output data to the machine learning model. The aim of supervised learning algorithm is to find mapping the function to map the input. In the real world, supervised learning can be used for risk assessment, image classification, fraud detection, spam filtering, etc. How supervised learning works? The diagram shows the labeled data contains all the shapes like triangle, square, and hexagon. We have to see all the labeled data into the training model. After this training model, the prediction algorithm predicts the output. Suppose we want to take the data as triangle and square. The prediction algorithm, once trained, the process is completed, the model is tested. On the basis of test data, we can get the output like square and triangle. Steps involved in supervised learning. We have to split the training data set into data set, test data set, and validation data set. Determine the input features of training data set. We should have enough knowledge so that model can accurately predict the output. Execute the algorithm on the training data set. We need validation sets and control parameters, which are subset training data sets. Evaluate the accuracy of model providing the data set, and if the model predicts the correct output, which means our model is accurate. Types of supervised machine learning algorithm. We have to classify it into two types. One is regression model, another one is classification model. Under this topic, regression model, the linear regression and regression trees, nonlinear regression, Bayesian linear regression, polynomial regression. Under this classification model, random forest, decision trees, logistic regression, and support vector machine. Linear regression in machine learning. Linear regression is one of easiest and most popular machine learning algorithm. It is a statistical method that is used for predictive analysis. In this algorithm, it shows linear relationship between a dependent y and one or more independent y variables, hence called linear regression. Since linear regression shows linear relationship, which means it finds how the value of dependent variable is changing according to the value of independent variable. This algorithm model provides a sloped straight line representing relationship between the variables. For this diagram, the slope line says the linear regression line. The blue dot indicates the data points. The x is the independent values, y is the dependent values. The formula of the dependent value y is equal to a0 plus a1 x plus epsilon value. Here the values x and y variables are training data set for linear regression model. Types of linear regression. Simple linear regression and multiple linear regression. If a single independent variable is used to predict the value of numerical dependent variable, such a linear regression algorithm is called simple linear regression. If more than one independent variable is used to predict the value of numerical dependent variable, is called multiple linear regression. Regression analysis. Regression is a supervised learning which helps in finding correlation between variables and enables to predict the continuous output variable based on one or more predictor variable. Regression shows a line or a curve that passes through all the data points and target predictor graph in such a way that vertical distance between the data points and the regression in line is minimum. The distance between data points and line tells whether the model has captured a strong relationship or not. Types of regression. Linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression, ridge regression, lasso regression, and finally logistic regression. Linear regression. It is one of the very simple and easy algorithm which works on regression and shows the relationship between continuous variable. It is used for solving regression problem in machine learning. The diagram shows linear regression. The x-axis is the experience, y-axis is the salary. The formula is y equal to ax plus b. Here y equal to dependent values, that dependent variables, that is the target variables. X is the independent variables, that is predicted variables. A and b are linear coefficients. Logistic regression. Logistic regression is another supervised learning algorithm which is used to solve the classification. In this algorithm works the categorical variable such as zeros and one, yes or no, or true or false. The predictive analysis algorithm which works on the curved line. Here x is the input function, e is the basic natural algorithm. It is used the concept of threshold levels. There are three types of logistic regressions: binary, multi, and ordinal values. Polynomial regression. Polynomial regression is a type of regressions which models the non-linear data set using linear model. It is similar to multiple linear regression, but it fits a non-linear curve between value of x and corresponding conditional value of y. Suppose there is a data set which consists of data points which are present in a non-linear fashion. So for such case, linear regression will not best to fit those data points. Polynomial regression, original features are transformed into polynomial features of given degree and then modeled using linear model, which means the data points are best fitted using polynomial line. Support vector machine. In this regression algorithm, which works for continuous variables. Here, kernel is a function to use to map lower dimensional data into a higher dimensional data. The blue line indicates the hyperplane. The hyperplane is separation line between the two classes. Boundary line. The boundary lines are two lines apart from the hyperplane which creates the margin of our data points. Support vectors. Support vectors are the data points which are nearest to the hyperplane and opposite class. A hyperplane which is the maximum margin, so that margin, the maximum number of data points are covered in the margin. The main goal of SVR is used to consider the maximum data points within the boundary lines, and the hyperplane must contain the maximum number of data points. Decision tree regression. It is solving for both classification and regression problems, both categorical and numerical data. Decision tree regression builds tree-like structures which each internal node represents test for an attribute, each branch represents the result of the test, and each leaf represents the final decision of or result. The decision tree is constructed starting from the root node to the parent, that is called parent node, which splits into the left and right like data structure, root trees and subtrees. The child nodes are further divided into their children node and themselves become the parent node of the nodes. Ridge regression. It is the one of the most robust versions of linear regression, which is a small amount of bias is introduced so that we can get better long-term predictions. The amount of bias is added to the model known as ridge regression penalty. This penalty by multiplying the lambda to the squared weight of each individual features. Ridge regression is a regularization technique which is used to reduce the complexity of the model. It is also called L2 regularizations. It helps to solve the problems more parameters than simple. Lasso regression. In this regression is another regularization technique to reduce the complexity of the model. It is similar to ridge regression, except the penalty terms contains only absolute weights instead of a square of weights. Since it takes absolute values, hence it can shrink the slope to 0, whereas ridge regression can only shrink it near to 0. It is also called as L1 regularization. These are the basic things we have covered under the machine learning. Thank you.